Okay, so here's another example of how we can use this. So once you get a couple of these examples in, it's just a matter of knowing what we're finding. That's why these graphs are good to draw out first, and then you can get an idea of what you're solving for. So here we have an example. A large investment bank in Miami released a report on the starting salary offered it made to MBA graduates. The salaries are normally distributed with a mean of $89,200 and a standard deviation of $2,100. Find the probability that a randomly selected MBA graduate was offered a starting salary of less than 92,000. So here, what we're going to look at, this is the curve that we want to look at. So we have our mean of 89,200. We have the question, which is asking what is the probability that someone would be offered less than $92,000. And we have a standard deviation of 2,100. So once again, what we want to find first is what is the standard deviation of that data, that 92,000. So we go back to our standardizing formula or solve for a z score. And we're going to take our x value, in this case it's the 92,000. We're going to subtract the mean from it of 89,200, and we're going to divide it by the standard deviation. And we get a standard deviation of 1.33. So once again, the two ways that we can do this, I'm going to go to my 50% table first, or my table that looks at the curve as half, and then this will kind of help. So when we go here, we had the standard deviation was 1.33. So I go to my 1.3, and then I go over to where my other 3 comes into play. So 1.33 falls right here, 0.4082. Okay. Now, once again, remember what that 0.4082 represents. That is the probability from the mean to that 92,000. So from here to here is 0.4082. But what we want to know is what's the probability of 92,000 or less. So once again, we got to go into the bank and say, okay, we know what this probability is, but we have to include this. And how we include that is just by our thinking that, or knowing that half of the curve is equal to 50%. So what we're going to do is we're going to take our 50% and we're going to add that 0.4082 to it, and we get 0.9082. So the probability that a new hire was selected at random, or a new graduate was selected at random and had a starting salary of less than 92,000 would be 0.9082, or once again, percentage-wise, we could round it to 91% is the percentage. Okay, so that's using the table as half. Now we can also go back and use the table. Now this is actually a lot simpler if we use our looking at the curve as a whole, because once again we have this is looking at the extreme left to that point. So if we go to our 1.33, what do you notice? We already have 0.9082. And once again, that's because it's looking at the probability from the extreme left to that point, which is exactly what we want to look for. So the answer that we get there is going to be the answer. So when using Excel, once again, that's what Excel will report out. So Excel would be, we only have one step to do in Excel, and that one step, and actually I'm just going to use this here and change my information. So it was 92,000 was what we want to observe. The mean was, what was our mean? 89,200. So 89,200, and our standard deviation was $2,100. $2,100, and I'm going to hit enter. And now we have our 0.908, and in this case 9088, which once again is going to be slightly different. And the whole reason is because when we go to the z-score of 1.33 in the tables, there's only 2 decimal places that it represents. for Excel, it takes into consideration all decimal points. Okay. So just another example. I'll do a couple more here just so you can kind of get used to and kind of have to fall back on.